So now we'll begin the fixed point iteration, and for this we first assume there's a function g of x where it is equal to x minus f of x. Now we know that if x equals to root, then f of x equals to 0. If x is the root of the function fx, then this will be 0. So let's replace these values with the root. So this becomes r and this becomes 0. So we can say at the root r equals to g of r. Now this can be used as an iterative process where we tend to go towards the root by using the function g of x. Now this is a naive approach of finding the root. Now from the fixed point iteration theory, we know if we can just separate the value of x, then whatever we are left with is g of x. So from this function we want to separate the value of any of the x's. So let us pick this one. So we take this to the left hand side and then we divide it by 6 and square root to find the value of x, and whatever is the value of x is also g of x as stated in the fixed point iteration theory. And there are multiple ways which you can find the value of x. So we could have also taken 2.5 x to the power 4 and we will be left with another g of x. So let us look at this equation to see how fixed point theory actually works. So for this equation, if we calculate via calculator, the roots we will find is 0.618 and minus 0.618. These are the dot dot dot. So these are the two roots that we will find from this equation. Now using the fixed point algorithm, first we have to separate one x. So what we can do is write x square equals x plus 1, and then we divide both sides with x, so we are left with 1 plus 1 by x. Now this is our x, so we can also write that this is our g of x according to the formula we have discussed. So g of x is equals to 1 plus 1 by x. And if we put in values and iterate through, we will slowly converge to the root. So let's assume the first value we put in instead of x is 1. So then g of x becomes 2. So let's write it as x of 1. So 1 plus 1 by 1, this becomes 2. Now we use this value and substitute it again with g of x. So g of 2 becomes 1 plus half, which is 1.5. Now we put 1.5 in g of x and then for x3 we will get 1 plus 1 divided by 1.5. We replace the value of x with this new value, and slowly we are getting close to one of our roots. And if we keep on iterating, we will slowly get towards this value. And this is the fixed point theory, how you can find roots with it. Now, if we look at the code, we will see that we have to make the three equations that we have found. So we found three g of x's. This is the first one, second one, and the third one. Now we just have to make them into numpy polynomials. So we give the coefficients first. So 2 is here, x is multiplied by -1, x squared is multiplied by 6, and the entire thing is divided by 2.5, and then to the power 1 by 4. So we get g of x and make it into a numpy polynomial. Now we just have to apply the fixed point. So we intend to find three roots which are a1, a2 and a3 from the iteration, and after each iteration we will save the value of a1 here, the value of a2 here, and value of a3 here. Each value will be updated in this loop. So now here you have to write the code. So what you have to do is you have to run a for loop. So you can run the for loop for at least 30 times. So you run the for loop, and inside the for loop what you have to do is save the value of a1 to g of g1 underscore a1, value of a2 to g2 underscore a2, and value of a3 to g3 underscore a. Now how will you get the new a1? So the new a1 will be g of the value of a1. So this is the fixed point iteration. You run this loop. If you run enough iterations, a of 1 will be one of the roots, and if you run this for three different equations, and finally the roots will appear in the graph. So f of x is the blue line, and you'll get at least 3 roots for f of x using the formula. So that's it for this lab.